All right, ELE 111, Section 7-1, Part 3. Trying to get you to become better at combining resistances. Here we're going to go through a bunch of actual calculations. You can see the circuit up on the top left is a series parallel mixed circuit. And the power supply, which is located on the left, that's exactly where the ohm meter needs to be inserted. So we pull the power supply out, we put the ohm meter out there, and as the diagram says, we start out here far away from the resistors next to the ohm meter. I will make note that this circuit does not have a resistor in parallel with the ohm meter that needs to freeze. So we can start combining further away, and you notice that R23, I'm hoping that you see that there is this parallel connection out here, and this computation produces something less than 2,000 ohms, which in this case turns out to be 1.2K. We drop that value in over here, and what our goal in getting into further sections of Chapter 7 will be is to learn to redraw. I can't overemphasize that. Learn to redraw. This is going to be the hardest thing for you to do, even though it should be the easiest thing for you to do. And when you call me for help, I can't help you unless I have drawings to look at. So what we've done is we've broken the series parallel circuit down, and we want to get it to a series circuit, which, because of the simplicity of this circuit, we've already achieved that. And so R23 and R1 and R4, which are out here, combine in series to produce 6.2 K ohms. Now, this would be a great circuit if we were trying to calculate all the voltages, which is coming. If we were, then we would start down at this circuit, because this is the simplest circuit. The one thing that circuit will give us is the total current. We do have the total resistance, so therefore we can find the total current in the circuit, which coincidentally, we might as well mention, that's what these two resistors out here see. They see that total current if we were calculating it. This is just a practice of combining resistors, so we'll move on. Here's circuit number 2. Another series parallel circuit. You only get good by practicing, and I want you to see that the power supply is in the middle this time. So we've got to break this circuit down and put the ohm meter exactly where the power supply is, and put all the other resistors back, and then try to move to the outside of the drawing to compress any resistors. The secret is in the drawings. So now that this resistor is in here, resistor 1, 2 is locked into place. There's no other resistance out there to combine with it at the moment. But what we do see to the right here in the green scribble is R3 and R4 are a series connection. So they get added up. 4 and 3 makes 7. And we end up down here with the meter in the middle, and both resistors are frozen. So we do this little manipulation move to redraw the circuit down here, and we haven't changed anything. We simply slipped the 666.666 ohm resistor over to this side and built this circuit. Trust me, it is exactly the same circuit. Then we have a parallel branch of R12 and R3, 4. And as you move through that computation, you end up with nothing but a series circuit down here in yellow. A simple series circuit, the total of which is 608.696 ohms. The way to look at these problems is not to just watch them, but to actually do some of the computations so that you can get from something that's dirty up there to something that's simple down here. And when we get further into Chapter 7, we're going to use this drawing right here labeled number 1 as our starting point for computing total current. And then we're going to jump to this circuit, then we're going to jump to that circuit, then we're going to jump to this circuit, all with the goal of finding all the voltages and all the currents in these circuits. Okay? So that can take quite some time, the first few circuits that you work. Let's move on. Here's an interesting circuit. We'll call this the triangle circuit. I want you to look at that first circuit, and what we want to do is we want to find the total resistance from points B, C. So points B, C would be right here. And I want you to understand, we've looked at a prior video, if you had watched it, that location is everything with the ohm meter. Wherever you put the ohm meter, if you have this relationship right here of a parallel resistor across both terminals, then you need to start away and you need to compress from the front side back. So because of that, we grab R1 and R3, and they're in series. So we add them. 15 and 5 is 20K. That takes us down to circuit 3 here. And lo and behold, now we're stuck. We're not really stuck, but we have landed a parallel circuit that when you combine 10 and 20K combines to 5,000 ohms. I recommend you practice these calculations with your calculator. So this is the circuit that we end up with. Your meter actually reads 5,000 ohms. And these problems, many of which are fairly similar to the ones that you're going to be doing for homework. So I've specifically picked them up so that you would be able to use these to do your homework with. Okay, here we go. We get to the big daddy, the big problem. You have some homework questions on this. It's not quite as difficult as you think once you know the tricks. And what we want to do is we want to find the resistance of the circuit from 3 points of view. RAB, which is located here, RAC, which is located here, and RAE from all the way out here to all the way out here. We want to install a current meter to measure and break down the resistance of this circuit. Okay, so the first case, RAB, is going to put a meter off to the left where you see it here in the green circle. If, well, maybe I can't draw it right now, but you can see it off to the left. RAB, here we go. There's the ohm meter inserted. Ask yourself, is R1 in parallel with the ohm meter? Answer, yes. Therefore, you cannot move R1 until the very end. I know you want to, but you can't. You can't just blindly go in and start grabbing things. So what we do is we've learned to start out here where the red X is. We've learned to compress backwards. Now this is a trick circuit in that the cluster between C and E, this diamond in the red circle, does not really exist in this problem, okay? I don't know how you want to add them, but I think that all of these components that are here in blue, I think that all of these components are a big series cluster, don't you? A big series cluster. We could grab them all. If you don't think that's the case, grab these two in series, grab these two in series, and combine them in parallel. But here's what you're going to find. No matter how hard you work, this cluster over here reduces to one resistor and one end has nowhere to go. Point E, whatever you want to call it, it has nowhere to go, and there's a resistance there, and it's hanging in the wind, basically. It's not part of the circuit. So the only thing that exists is the left side of that diamond where I've just circled. That's the only thing that exists. So as long as we're measuring, now listen to what I say because you have homework problems. As long as we're measuring from A to B, this side doesn't exist. As long as we're measuring from A to G, this side does not exist. If we're measuring from B to C over here, that side does not exist. If you're trying to measure from G to C, this side simply does not exist. The only time, I could even measure from A to C, and that right side simply does not exist. Okay, so let me open up here. There we go. Let's grab that. Okay, now, that being said, since that side does not exist, then we can move on and solve this portion of the circuit down here, circuit 3. These three resistors combined, they are all in sequence. There is no break, there is no extra connection spots. We can add those three together, and they very graciously combine down here to form a 7,000 ohms via this calculation right here. 7,000 ohms of series resistance, and we end up in a parallel which converts down to a single series resistance of 2.1 k ohms. So again, to summarize, as long as your meter is in between these 4 points, whether it's A, B, A, G, A, C, or B, C, or B, G, the whole right side does not exist. Okay? Just want to make you cognizant of that. That's part 1 problem. Second problem, I've just installed the meter between A and C, and if you learned anything from the last slide, this side does not exist. It is not required. So, now the meter's in a different spot. So, we've got 2 resistors in the green area down here that appear to be series, and technically you could add those. That'd be 4,000 ohms, okay? Here it is right here, 4,000 ohms. And technically on the top, you have 6,000 ohms right here. So you could add those. When you add them, looky, you end up in parallel again. And when you combine 6,000 and 4,000, you'll get something less than 4,000, and in this case, if my computations are right, you're going to end up with 2.4 k ohms or 2,400 ohms. Isn't that interesting? You are now an expert at working the left side of the diamond. Here's the last step. This is interesting. We're stretching our ohm meter from one end of the diamond clear across to the other end. That means that we no longer can ignore one side of the diamond. So in your homework, if they ask you to calculate, anything from this point to here, from A to here, all of a sudden, both sides of the circle, if you're connecting to any of those three dots, and we are in this problem, then both sides of the diamond exist, okay? There's a full path. So what we do is we start by combining, by looking away, as you can see here, where I've circled. We're going to start combining in the red area, and we look away and we look at that red area, and that is not 4 resistors. That is not 4 resistors in series. That's because the little junction that you have here, little junction, gets in the way. So what we have to do is we have to attack in a little bit smaller controlled area. We grab these two parts and we grab these two parts, producing exactly what we see here. 4,000 and 4,000 makes 8,000. 3,000 and 3,000 makes 6,000. And that's how we get that particular portion of the diamond happening. Okay? Now, you have to remember that your meter is sitting across E and A. So, the same way we combined the top, we are now going to combine the bottom two here and the bottom two here. You will have some of this to do in homework, so I would definitely take some notes and have some material available to look at rather than just watch the videos over and over. Now, that allows both 7 and 8 and 5 and 6 to combine into 4K and 10K, which are shown down here at the bottom. And that produces 2 parallel sections. Do you see that? Do you see those 2 parallel sections? Let me get to a different color here so that I can show you. Those 2 are in parallel, and these 2 are in parallel. The secret is this junction that's in the middle separates the 2 paths, and you have to respect that. So we do R12 in parallel with R78, and we come up with 1278, which is 2.4 k ohms over here on the left, and we combine the R56 with 3456 is combined from 3456, located up here, and we end up with 4.4 k ohms. And as you can see down in the bottom here, when you add those together, this circuit produces 6.8 k ohms of resistance. Hopefully, these videos will help you get through some of your homework. I recommend making notes. I recommend redrawing drawings over and over and over and using lots of paper.